Everyone, and welcome to today's lesson 6.2. Today we are going to talk about trapezoids and their properties. Now, a trapezoid is a quadrilateral, a four-sided polygon with exactly one pair of parallel sides. And we have two different sets of bases, one pair of bases. That's that pair of parallel sides. So in this case, that would be side TR and PA, because again, those are the parallel bases. And then the non-parallel sides are called the legs. So that would be side TP and RA, the non-parallel sides. So here and here. Our base angles then are the consecutive angles that include each of the bases. So for instance, there's two sets. We have angle T and angle R would be one set. And then the second set would be those lower base angles. In this case, that would be angle P and angle A, then would be your lower base angles. Again, they make up either side of each of the bases. Now, our same side consecutive or interior angles, those are going to be supplementary to each other. So what this goes back to is back when we talked about parallel lines, right? So again, these two lines here are parallel. And if we cut the parallel line by a transversal, then their same side interior angles are supplementary, right? Going back to our parallel line information. So for instance, angle T and angle P, whatever they are, they're going to add up to equal 180. And then the same thing is going to happen for that other pair of interior angles, angle R and angle A. Those would also be supplementary because they're same side interior. Now, another important theorem then involves when we have a special type of trapezoid, and that's an isosceles trapezoid. And what happens is that isosceles trapezoids occur when your legs are congruent. So BA, the first leg, is congruent to CD, the other leg. That's showing that that's an isosceles trapezoid. And when that happens, our base angles are not only going to be supplementary to their corresponding consecutive angle, so angle B and angle A are supplementary, and so are angle C and angle D. But the base angles are congruent to each other when we have an isosceles trapezoid. So angle B and angle C would be congruent, angle A and angle D. So upper base angles and then lower base angles are congruent. So in example 1, if we want to figure out what are the remaining angles in this isosceles trapezoid, right? We know that those two legs are congruent. We know these upper base angles would be congruent to each other, and the lower base angles are congruent to each other. So if angle R is 135 degrees, so is angle Q. And then each of the consecutive lower base angles are supplementary to the upper base angle. So if we do 180 minus 135, we could get the remaining angle for P here, which is 45. And again, that needs to be the same measure then for angle S. So angle Q, we would say, is 135 degrees. And then angle P is 45. And angle S is also going to be 45 degrees. Now down below, we have another isosceles trapezoid. And again, in this example, they want us to solve for a couple of missing pieces, X, Y, and angle T. So we have these upper base angles and lower base angles. Well, we know angle R and angle S, upper to lower, are going to be supplementary to each other. So we can take those two angles, 7x plus 5 plus 35, and we know that those two are going to equal 180 degrees. So if we combine, we have 7x plus 40 equals 180 if we combine on the left. And then if we subtract over the 40 and divide by the 7, we end up getting x to equal 20. Right now, we also know that the lower base angles are congruent. So if we're trying to solve for y, we can take the y minus 11 angle u, and we know that that's going to have to equal 35 degrees because those two lower base angles in the isosceles trapezoid are going to be equal. So y is going to equal 46 on that one. Last but not least, angle T, needs is the final thing we're trying to find. So we found x, we found y, we need angle t. So again, we know that these two angles are congruent. And then again, our upper to lower base angles are supplementary. So 180 minus 35 gave us 145. Here is an example on the back page then for you to try. You are just finding the numerical measurements of the missing three angles in this isosceles trapezoid. Now, another theorem that is special to our isosceles trapezoids is that the diagonals are going to be congruent. So each diagonal A to C is going to be equal to the measure of B to D. So on this one, if they're telling us U to W is x plus 13 and V to X is 2x minus 1, we know that those two measures must in fact equal each other. So I'm going to subtract 1x from both sides and end up with 1x minus 1. Add the 1. X is going to equal 14 this time. So another example for you to try. This time they're giving you A to P and N to L, and you are again going to solve for X. All right, the last big piece of information for today is the idea of a mid-segment of a triangle. It's also sometimes called the median, not of a triangle, of a trapezoid. And what the median or the mid-segment does is it basically connects two different midpoints. So for instance, X is the midpoint of AB, it splits that in half. Y is the midpoint of CD. So again, when it connects these two midpoints, what happens is this value in the middle, the mid-segment, is 1/2 of base plus base. Okay? So again, it connects those two midpoints. Now, how do we actually use this to help us find segment length? So in this example, we are looking for the length of that mid-segment, which is P to Q. So in order to find this value, we are going to add up our two bases and divide by 2, or take 1/2 of our two bases. So 1/2 or 0.5 of our two bases, 54 plus 33 is 43.5. Okay, so that would be the length of that mid segment. And again, that makes sense because that number is directly in the middle of our two bases. What happens if you're not looking for the mid segment? Instead, you're actually looking for one of the bases. Well, the facts don't change, right? The mid segment is going to equal 1/2 of our base plus our base. This time, though, we just happen to be looking for the value of one of those bases. Now, instead of distributing this 1/2 to both sides, to get rid of the 1/2, what we're going to do is we're going to multiply both sides by 2. So if we double the mid segment, it equals base plus base. And then last but not least, subtract over, and we have our missing base would be 4 units. Okay, and again, this makes sense. If I went down 16 to get to 20, and I go down 16 more, I got to 4. So you can kind of double check mentally, oh, I subtracted 16. I'd have to subtract 16 more to get to my other base, again, because it's directly in the middle. Right, so we have two examples for you to try. The first is asking you to find the value of your missing mid-segment, TU. The other is asking you to find the value of the missing base given the mid-segment. All right, our last type of examples are going to be involving taking some algebra to solve for x using that value of the mid-segment. So again, we can take the mid-segment, in this case, that's x plus 19, and we know that that equals 1/2 of 19 plus 31. Well, 19 plus 31 is 50. Half of 50 is 25. And then to get x by itself, we end up subtracting the 19 over, and we end up getting x to equal 6. So again, there is one last example for you to try. Given the value of your midsegment, solve for x given the bases in that midsegment expression. Thanks everyone for watching. We'll work more with our trapezoids in class.